Good morning, students. Now we are going to discussing about foot and image theorems. Here foot theorem is already we know about foot theorem in previous class. If h comma k is foot of the perpendicular of some point x1 comma y1 with respect to the line some ax plus by plus c is equal to 0, then prove that h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by a square plus b square. Okay, so based on this equation we can find the foot of x1 comma y1 with respect to this line ax plus by plus c is equal to 0. Okay, see here proof is let p h comma k, let us consider the point p is some h comma k and that is the foot only. x1 comma y1b is some a and this line is represented with some L, ax plus by plus c is equal to 0 for our convenience. So what is the foot of the perpendicular? Already I discussed. So let us consider this is the line ax plus by plus c is equal to 0 and this is the point ax1 comma y1. So whenever if you drop a perpendicular from a to this line where this perpendicular meets on this line ax plus by plus c is equal to 0, that point is called the foot of the perpendicular of ax1 comma y1 with respect to this line ax plus by plus c is equal to 0. Okay, so very clear observation we can see here. This is AP is nothing but perpendicular to this line ax plus by plus c is equal to 0. Whenever this line is perpendicular to this line, then product of their slopes is equal to minus 1. This is very useful condition here. And one more observation we can see, this foot of this ax1 comma y1, foot of the perpendicular of this ax1 comma y1 is nothing but lies on this line ax plus by plus c is equal to 0. So through this diagram or through this concept we can observe two conditions. Based on those two conditions we can prove this theorem. Very easy. Okay, now I am using products of their slopes is equal to minus 1 because these two are perpendicular. So what is the slope of AP line? If you know the 2 points, so slope is nothing but some k minus y1 by h minus x1. That means y2 minus y1 by x2 minus x1. Slope of the points, that means slope of the line passing through the points x1 comma y1 and x2 comma y2 is y2 minus y1 by x2 minus x1. If you use that formula, what is the answer here? So k minus y1 by h minus x1. This is the into slope of this line very clearly minus coefficient of x by coefficient of y, that is minus a by b is equal to minus 1. This minus get cancelled and here we can say you can multiply numerator and denominator separately. So a into x k minus y1 by b into h minus x1 is equal to 1. Then we can say a into x k minus y1 is equal to, if you transpose denominator we have b into h minus x1. So I am writing separately based on this condition what we need to prove. Okay, that means h minus x1 by a, this a transpose to right side and b transpose to left side. So h minus x1 by a is equal to k minus y1 by b. Now I am giving one wonderful formula in 8th class ratio and proportions, that is that theorem is called as the law of multipliers in ratio and proportion. This is called the law of multipliers in ratio and proportion. What it says, if a by b is equal to c by d, then we can say, and that means if whenever two ratios are equal, this is a by b one ratio, c by d one ratio. So if these two are equal, then we can say these two ratios are also equal to another one, that is nothing but LA plus MC by LB plus MD. Here L comma M are any constants, any numericals, no problem, you can take any numericals, any number, any real number you can take. That means if A by B is equal to C by D, then this ratio is equal to LA. That means what number you are multiplying to numerator, same number we have to multiply to denominator here for the first ratio. And for the second ratio, what number you are multiplying for numerator, for denominator also we should multiply same number and add corresponding numerators and corresponding denominators. What it says, let us consider if you multiply L to A and B, M to C and D, then what can you say? That is equal to LA plus MC by LB plus MD. If you want to prove this one, so you take one example. For suppose, very clear. For suppose 1 by 2 is equal to 2 by 4. Yes, very clear. 1 by 2. If you 2 4 4 2 times going, so this is also 2 by 4. If you want to multiply any number, just if you multiply with 3, okay, 3 multiply to this ratio, 4 multiply to, or 5 multiply to this ratio if you multiply. So 1 3s are 3 plus 4 multiplying. So this one multiplying with 3, this one multiply with 5. So 2 5s are how much? 10 by. So 3 multiplying, 3 2s are 6 plus here 4 5s are 20. Simplify this one. So 13 by 26. So 13 in 26 2 times going, that is also equal to 1 by 2. So 1 by 2 is equal, 2 by 4 is equal 13 by 26. Yes. So this is the law of multipliers in ratio and proportion. It was in 8th class only, 8th or 9th class. Don't know exactly. So you just remember this formula. This is very useful formula. But here, to prove this one, h minus x1 by a is equal to k minus y1 by b is equal to, I am multiplying for the first ratio. What number if you want to multiply 2 also you can multiply. If you want to multiply 1 means no meaning. So if you want to multiply 4 also we can multiply, no problem. But for our convenience, I am multiplying first ratio to, for numerator and denominator, a. For second ratio, I am multiplying b. So what can you say? A into this ratio is equal to a into h minus x1 plus b into k minus y1 by a into a square, plus b into b square. That means for first ratio I am multiplying with a, second ratio I am multiplying with b. So what is the, according to this formula, so what number you are multiplying? That multiplication plus this multiplication by here denominator multiplication plus this denominator multiplication. Okay, so that means a into h minus x1 plus b into k minus y1 by a square plus b square we have. Okay, according to this formula. Here I multiplied with a. Here for this one multiplied with b. That is the important we have to remember. Don't get confused. Okay. So if you simplify this one, what you have? Ah plus bk minus ax1 minus by1 by a square plus b square. See here, this ah plus bk, it is nothing but, from this one you can say ph comma k lies on ax plus by plus c is equal to 0. So use second condition here. That means h comma k satisfies this line equation. That means ah plus bk plus c is equal to 0. ah plus bk plus c is equal to 0. That means ah plus bk is equal to minus c. Yes, ah plus bk is equal to minus c. So here ah plus bk you can replace by minus c according to this condition. So this is nothing but minus c minus ax1 minus by1 by a square plus b square. So totally we have here minus c minus ax1 minus b1 by a square plus b square. So this is equal to, so take minus common from these numerator 3 terms. So ax1 plus by1 plus c by a square plus b square. So totally we have h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c by a square plus b square. So this is the proof of this one. From this one, if you want to find the image of some x1 comma y1 with respect to this line, you have to substitute x1 comma y1 in this equation. If you want to get h, equate these two. If you want to get k, equate this one. Then you can say h comma k is image of x1 comma y1. You see one example after image theorem. Okay. So both are same, only little bit difference is there. So image theorem. What is image theorem? If h comma k is image of x1 comma y1 with respect to line ax plus by plus c is equal to 0, then prove that h minus x1 by a is equal to k minus y1 by b is equal to minus 2 times of ax1 plus by1 plus c by a square plus b square. Here in image theorem we have minus 2 times is there. For foot of the perpendicular theorem, we have only minus of ax1 plus b1 plus c by a square plus b. Remaining parts are same to same. Okay. So proof of this one. So before proving, first I am considering this point is some p h comma k, that is the image of this point x1 comma y1. You denote with a. This line you denote with ax plus by plus c is equal to 0. So what is the image? First we have to remember. So let us consider this is the any plane surface or line L is equal to 0. Okay, so this is line L is equal to 0. So if the image of ax1 comma y1 with respect to this line is some ph comma k, that means whenever you take for any point image with respect to this line will be how much distance this line to a, same distance it bears with p also. Okay, that means we can say very clearly, and image always going, that means if you join that point and image, that is always perpendicular to the with respect to the line. Okay, that means after plotting this a comma p, this line is always perpendicular bisector of ap, perpendicular bisector of line segment AP. That means whenever if it is the line equation, so the distance from A to some M, it is the point of intersection of AP and L is equal to 0. AM is equal to MP, same distances, and this AP is perpendicular to L. So here we can understand one thing. Here M is the midpoint of AP, very clear answer. M is midpoint of AP, and that midpoint always lies on L is equal to 0. Yes. So we can use one condition here because of midpoint lies on L is equal to 0. First we have to find out the midpoint and substitute on line ax plus by plus c is equal to 0. We get one condition, and one more condition is that is very clear condition. This line AP is always perpendicular to this line L is equal to 0. That means if AP and L are perpendicular, mutually perpendicular, then product of their slopes is equal to -1. So use this one. So if P is image of x1 comma y1, then we can say first condition, this is midpoint of AP lies on L is equal to 0. So what is the midpoint of AP? Very clear. What is the midpoint of AP? Midpoint formula x1 plus h by 2 comma y1 plus k by 2. Okay, y1 plus k by 2. So this lies on ax plus by plus c is equal to 0, means in the place of x substitute x1 plus h by 2, in the place of y substitute y1 plus k by 2. So substitute here. So what we have? A of x1 plus h by 2 plus b of y1 plus k by 2 plus c is equal to 0. So simplify. What you have here? 2 is the LCM. So take 2 LCM and multiply numerators. So a into x1 plus ah plus b into y1 plus bk plus here there is no 2, so it becomes to 2c whole by 2. If you transpose the 2 to right side, 0 into 2 gives 0 only. So totally we have ax1 plus ah plus by plus bk plus 2c is equal to 0. Here ah plus bk, I am making ah plus bk as subject. Why you are making this subject means we can understand in the second condition. Okay. So ah plus bk is equal to, if we transpose remaining terms to right side, minus ax1 minus this is minus by1, okay, minus 2c. So take this is the equation 1. Now second condition is what here? AP is perpendicular to L is equal to 0. Therefore slope of AP into slope of L is equal to -1. So slope of AP is what here? Same, k minus y1 by h minus x1. And the slope of the line ax plus by plus c is equal to 0 is minus a by b. So is equal to -1. This minus get cancelled, and totally we have a into k minus y1 by b into h minus x1 is equal to 1. So this b into h minus x1 transposed to right side. Then we have a into k minus y1 is equal to b into h minus x1, and according to the our condition, so we have to frame this equation as h minus x1 by a, this a transpose to right side, b transpose to left side. We have h minus x1 by a is equal to k minus y1 by b. So this implies h minus x1 by a is equal to k minus y1 by b is equal to, same you have to apply law of multipliers in ratio and proportion. So same thing we have to, what you multiplied in image theorems, sorry, put of the perpendicular theorem, same you have to multiply. So both for first ratio multiply with A, second ratio multiply with B, and we have to apply that law of multipliers. So what we have, h minus x1 by A is equal to k minus 1 by B is equal, for first ratio multiply A, that means A of h minus x1 plus B of k minus y1 by, so A into A square plus B into B square. B square. Okay, so this implies, simplify, ah minus ax1 plus bk minus by1 by a square plus b square. So here also we have ah plus bk minus ax1 minus b1 by a square plus b square. So according to first equation, what you have, ah plus bk is equal to minus ax1 minus by1 minus 2c minus ax1 minus by1 by a square plus b square. This is equal to, so here minus ax1 minus 2ax1 minus by1 minus 2by1 minus 2c is there. So from this one, if you take minus 2 common, totally we have ax1 plus by1 plus c by a square plus b square. So totally this is equal to h minus x1 by a is equal to k minus y1 by b is equal to minus 2 of ax1 plus by1 plus c by a square plus b square. This is nothing but image theorem. Very, very clear. So now you just remember based on this one some applications. Very easy. You can remember, already I gave these applications in coordinate system, first topic. Okay, so mostly new joiners we don't know, but you discuss after some time. Okay, image of, until you just remember these formulas, image of curve whose equation f of xy is equal to 0 with respect to, here f of xy means any line, that means that is maybe some ax plus by plus c is equal to 0, x square plus y square is equal to 2, 2x square plus 3x plus 7 is equal to 2, like that, any equation in terms of x comma y, whatever may be. Okay, that is the represented with some f of x comma y. That means, for suppose one example you take, some 2x square plus 3xy plus 7 is equal to 0. This is some f of x comma y is equal to 0. It is the equation in terms of x comma y. So that is the importance we have to remember. So like that, any equation you have, if you want to find out the image of this curve, for suppose if you take example with respect to x-axis, with respect to x-axis means this is the curve, this curve may be like this, whatever may be, this curve may be like this, this is x is equal to 0. So this image may be like this, whatever may be. Okay, so this curve equation is this one, for suppose if you understand. So this image may be like this with respect to x-axis. Then this curve equation is f of x comma minus y is equal to 0. That means in the place of x you substitute x only, in the place of y you substitute minus y. Then what you get the equation, that is the image of this curve with respect to x-axis. Similarly, same curve with respect to y-axis, if you want to find out the image with respect to y-axis, that is nothing but f of minus x comma y is equal to 0. With respect to x-axis, y changes its sign. With respect to y-axis, x changes its sign. Just same, remaining are same to same, remaining all terms. Okay, next with respect to origin is, so both x and y changes its signs. F of minus x comma minus y is equal to 0. Next one, for suppose the image of this curve f of x comma y is equal to 0 with respect to the line x plus y is equal to k. Here x coefficient and y coefficient both are positives with 1. So only x plus y only is equal to any constant, no problem. If the line equation is in this form, then that image is nothing but f of k minus y. In the place of x you take x k minus y. In the place of x in the place of y you take k minus x is equal to 0. That means you replace x by k minus y, replace y by k minus x in this equation. Okay, whatever may be that, let us take, I took one example only. Whatever maybe they give the question, you go for, this is the procedure. Okay, so how to remember these formulas. X plus y is equal to k is with respect to the image of f of x comma y is equal to 0. With respect to x plus y is equal to k is f of k minus y comma k minus x is equal to 0. So based on this one, we have one more. This is very, very important. Image of x1 comma y1 with respect to the point h comma k. image of x1 comma y1. Here this is the image of any point with respect to the line. Here image of point x1 comma y1 with respect to the point, any point h comma k, is the formula is 2h minus x1 comma 2k minus y1. So 2h multiplied 2h, 2h minus x1, 2k minus y1. So these are the formulas. We will discuss based on these questions in next video.